podcast, you'll see how to solve a projectile motion problem, or also known as a motion in 2 dimensions problem. The problem reads, a woman hits a golf ball at initial speed of 25 meters per second at an angle of 30 degrees to the horizontal near the edge of a cliff. The cliff is 35 meters high. How far from the edge of the cliff will the ball land? How long is the ball in the air? And how high above the launch height does the ball go at its maximum? So, first let's draw a picture. So, pretty exciting golf course here. Here's the cliff. Like so. Here's the golf ball. And it'll go like this. Oops. And land somewhere over here. And we know that the initial velocity was 25 meters per second, and this angle right here was 30 degrees. We also know this height here is 35 meters. Hope she has a good plan to recover that ball. How far from the edge of the cliff will the ball land? So this is what part A is asking for. How high does it go above its launch height? So also asking for this. And then the third thing it's asking for is time. Whole time in the air. Okay, so the first thing we have to do is split the initial velocity into components because vertical and horizontal vectors are independent of each other. So let's draw our triangle for our initial velocity, like so. And this will be Vx, and this will be Viy. This is just Vx, not Vix, because there is no force acting in the x direction, so the x velocity will not change. We know the hypotenuse, but we don't know the sides, so let's use SOHCAHTOA. So sine of 30 is equal to opposite, Viy, over hypotenuse, 25. So 25 sine 30 is Viy, and then cosine of 30 is equal to adjacent Vx over hypotenuse. So 25 cosine of 30 is equal to Vx. And put those in the calculator. Putting those in the calculator, we get 12.5 and 21.6 meters per second. There. Now the next thing we have to do is remember we have to treat our x variables and our y variables separately because they're independent of each other. So let's fill out the first line that we always know, which is acceleration is 0 in the x direction, and the acceleration is negative 9.8 meters per second in the y direction. Now we want to know this x distance, so let's see everything we know in the x direction and see if we have enough information. We probably need to solve for time first, but we'll write it out. So Vx, we know, is equal to 21.6 meters per second. We don't know the distance. Oops, this says the edge of the cliff, so the cliff is actually right here. The moon is actually launching from right here. So there's not an extra x distance. So it actually kind of goes like this. There we go. Sorry about that. And we don't know anything about time, and we don't know anything about distance, so we're going to have to move on. We got nothing over here. In the y direction, we know that VIY is equal to 12.5 meters per second. We know from the beginning all the way to the end that the difference between this position and this position, d, is negative 35 meters. So that gives us 3 pieces of information, so we can solve for our time. And time is very useful in these because time is in a lot of equations. So let's go ahead and do that first. And let's see. We don't know anything about VF. Yeah, let's go ahead and solve that one first. So actually, we'll solve for VF first because then we can avoid using the quadratic equation. Not that there's anything wrong with the quadratic equation, but it does take a lot of time and algebra to solve it out. So we'll use this one, VF squared equals VI squared plus 2AD. VF is what we're solving for in this case. VI is 12.5 squared plus 2 negative 9.8 d. So if I put that in the calculator and then take the square root, so I have VF instead of, and remember this is negative 35 right here. So it's 12.5 squared plus 2 times negative 9.8 times negative 35, and put that whole thing in the calculator, take the square root, and you get 29.0 meters per second. Now that we have that, we can substitute it into a much easier equation and solve for time with VF equals VI plus AT. So 29.0 equals, oh, and this will be negative 29.0 because it's going down. But this is positive 12.5 because it's going up. Plus negative 9.8 times t. Extend my page a little bit so I have some space. I'll just show you my algebra here. Minus 12.5 because I'm subtracting from both sides equals negative 9.8 times t. So if I add those two together, I get a negative number. Divide by negative 9.8, I get a positive number, which is, and that gives me a time of 4.23 seconds. Now that I know my time, I can go over here because time is the same in the x and the y. It's the one variable that surpasses the x and y column. You can put it in either one. So I would like to know d, what I'm solving for. So we'll use d equals VIT plus 1/2 AT squared, using 3 out of our 4 motion equations in this problem right here. D equals VI 21.6. Whoops. 21. And I'll write it down here. 21.6 T 4.23 plus 1/2 A T squared. So since this is 0, anything multiplied by 0 is 0, so that whole term goes away. So D is equal to 91.4 meters. So let's go back to our picture. Actually, let me redraw our picture down here since I made a little bit of a mess of it earlier. We had a cliff, like this, went down like this, and there was a golf ball right on the edge, and it went like this, like so. And let's see if we have solved for everything. This was 25 meters per second. This angle here was 30. Well, it looks like a lot more in my picture. So this 91.4 meters is right here. 91.4 meters, right? We already knew that this was 35. Right here. I think we have one more thing to solve for. We know that the total time is 4.23, but I believe it asked us for the height. Yes, how high above the launch height does the ball go at its maximum? So we have one more thing to find, which is this height right here. So let's use the black pen. This is going to be with our y information. And this time, instead of saying VF is an unknown, we're going to say that VF right here is 0. So VI, y, is equal to 12.5. VF, y, is 0. It's still going across horizontally at that point, but it's not going up anymore. And it's not going down. D is what we want to know. A is negative 9.8 meters per second squared. Need some more space here. And D is what we want to know. So VF squared equals VI squared plus 2AD 0 equals 0 squared technically equals 12.5 squared plus 2 negative 9.8 D. So 0 squared is 0. Negative 12.5 squared equals negative 19.6 D. And then if I put that in a calculator, I will get a positive number of 7.97 meters. And that's the height right here above the cliff, how much further it went. And that is just about everything you can ask for in a projectile motion problem.